Hi, and welcome to 3.4H Asymmetric Freefall. In this lesson, students will be able to calculate and fully describe the motion of an object being thrown upward and then being caught at a different height from which it was thrown. So no longer is it going to be symmetrical like we did last time. It adds another level of critical thinking that you'll have to do. So here's the situation. The ball is thrown up and reaches its maximum height where its velocity is 0. So there it is on the ground, and its initial velocity was 5, but then it slows to 0 for a very split second. Then the ball drops to a different height in these from which it was thrown. It could be above the ground, or maybe it's allowed to fall even further down below from where it was initially launched from. Like maybe if you're standing on the edge of a bridge or something like that, and you toss something upward, and then it goes down underneath where it was. This can be viewed as a separate problem. So this was the final velocity at the first, we'll call it the first segment, and then you can like partition it into a second part, and I'll call that the second segment. And notice I'm not calling it the first half and the second half because it's no longer half and half. It's not symmetrical. It's not even. So this is the initial velocity in the second segment, and it comes down and then it stops right there. Maybe somebody catches it above the ground. So a couple of the things that we said last time aren't true anymore. The time up is not equal to the time down. It takes more time during the first segment to reach the maximum height, and then it's actually less time during the second segment because it doesn't go down as far. It doesn't have to do the whole path. In addition, the initial velocity is not equal in magnitude to the final velocity anymore. Ask yourself this, remember the initial velocity was 5 meters per second upward. This new final velocity, is that going to be greater than or less than the original initial velocity? What do you think? It's going to be less than in this situation. You didn't have enough time to get to that 5 meters per second. It's going to be less than 5 meters per second because it still is accelerating, but it didn't have enough time to get to 5. Also, the thing that is still true is that the velocity at the top is still 0, and we can break it up into segments now, the first segment and the second segment, and we can either make that 0 the VI or the VF, or we could just ignore the fact that, okay, yeah, we know that that's 0, but we don't have to use that in our calculations if we want to look at the full path of this thing. If we want to look at the total time, for example, we wouldn't necessarily care what the velocity was at the top. So there's a couple different ways to tackle these problems, and you kind of have to be a savvy physics student and do some critical thinking. It's not going to be the same thing every time. So that's going to be some fun problems. So for example, a toy on the ground shoots a ball in the air. The ball reaches its maximum height and then is caught 0.75 meters above the ground 3 seconds after it's shot. So it's like the scenario we just saw. What is the initial velocity of the ball, and what is the maximum height that the ball reached? So I'll draw myself a picture. It's always helpful to draw a picture. Give myself some room here. All right, so here's the ball on the ground, okay? And just so we know, the ball is going straight up and then coming straight back down, and then it stops here, 0.75 meters above the ground. But it's a little, since it's like on top of itself, the path is on top of itself during this portion, I like to kind of spread it out like this instead. So here's the ground, here's the ball, and then it's launched upwards, and then it comes down, still going straight down, and then like that. The reason I'm specifying that is because we are going to do problems that are projectile problems, and the ball has some horizontal velocity and some vertical velocity, and the the resultant velocity looks like that. So the ball's path will look in this parabola shape eventually. But right now, luckily, we're not doing a horizontal velocity. It's only the initial vertical velocity. So really breaking it down. It's important that you understand how to handle it when it's one-dimensional before we add a whole other dimension into the mix. So try your best here. So I like to write as much as I can on the diagram. The height is kind of where I always start. So the height above the ground where it's caught, the displacement is 0.75 meters. What else do they tell you? They tell you the total time. So T total equals 3 seconds. And we're assuming that we're on Earth, so don't forget A is equal to negative 9.8 meters per second squared. Even though they don't tell you that number in the problem, it is still very useful information. So that's about it. Now they're looking for the initial velocity. So I'll even draw this vector in and be like VI equals question mark on my diagram. It's helpful to have a picture of what's going on. Again, like I said on the previous slide, it's not going to be the same situation every time. So drawing a picture like this will help you analyze the situation. I know it seems like a little bit more work, and we don't like to write things down because it takes up time, and I know you're very busy. I know you are, but it is helpful. So that's why I do it. So what is the initial velocity? Then I ask myself, do I have enough information right now? And what I'm looking for is 3 numbers. If you have 3 pieces of information, you can find everything else. And I'm also looking to see, is this for the whole, are the numbers for the whole path? So the acceleration is the same throughout the entire path, so that's good. I have the total time, and this is the distance for the total path. In other words, I'm not doing the partition method yet, and I don't have to worry about this and be like, oh, I only have the time for this part of the motion, so that's not going to help me as much. No, I'm seeing if they agree, if everything agrees. And they do. So we have D, A, T, and we're looking for VI, so we do not care about VF. So we want the equation without VF in it, which is D is equal to VIT plus 1/2 AT squared. Now I know it's a little bit weird, but the displacement is 0.75 meters, positive, because again, the ball goes up and then comes back down. So from start to finish, you're going 0.75 meters. Remember, displacement is only measured from start to finish. You don't care about the rest of the path. So you just need the 2 points. 1, 2, and then what is the displacement? 0.75. So this is equal to VI times 3 plus 1/2 times negative 9.8 times 3 squared. I'm sure you could do the algebra on your own. You end up getting 14.95 meters per second. And it even pops out a positive number for you, which is what we would expect because our initial velocity is pointing in the upward positive direction. So remember, up is positive, down is negative, and the math works out to give you a positive number. So that's one way to check to see if you're doing it right. For part B, they say, what is the maximum height? So now I kind of alluded to it before. We are going to have to keep track of, I can't use this total time anymore. That's not going to be useful for me because that's telling me the whole path, but the maximum height occurs in the middle of that path. So it's going to be less than 3 seconds to get there. So we do know one thing though, the velocity is 0 meters per second at the top. Okay, I could still use the acceleration. Ask yourself, can I use this displacement? No, I cannot because they're looking for the displacement. What is this maximum height? So they're looking for the D, you could call it D max if you want. Okay, so far we only have two numbers. What else do we need to know? Oh, okay, so the problem kind of scaffolded it for us. We now know what the initial velocity is. And even if you're looking at the first segment, think of about what you know. The final velocity is 0, and now we know the initial velocity, we calculated it to be 14.95 meters per second. So we could use that value in our first segment calculation analysis. So just to recap, we know that the initial velocity is positive 14.95 meters per second. We just calculated that. The velocity at the top is 0, so that's VF. We know the acceleration, and we're going to look for D. So we don't care about what the time is, so you look for the equation that doesn't have a T, and you're going to use VF squared equals VI squared plus 2AD. You substitute in, and when you solve, you get positive 11.4 meters. And then you ask yourself, okay, does this value make sense based on what the problem's telling me? The problem said that it goes up and then comes back down, and it's caught 0.75 meters above the ground. So it would make sense that the maximum height is greater than the height where it was caught. So you could kind of visualize what's happening in the problem there. So I make it look easy, and spoiler alert, I did this ahead of time, so I'm looking at the work that I already did. I know I'm blowing through this in the interest of time. It's okay. You might have to look at this for a while and try to figure out and do some critical thinking. Okay, what do I have? What do I know? What can I infer from the problem? Like the fact that the velocity at the top is 0. How am I going to use that piece of information? And then while you're doing all that, don't forget that the acceleration is also known the entire time. So that's a key piece of information. I'll do one more with you. This one's going to be a little bit different. So you'll see like how it's not the same problem every single time. You have to handle the situation that's being thrown your way. So it says you throw a ball upward and let it hit the ground. The ball leaves your hand with a velocity of 15 meters per second from a height of 1.5 meters. So they're giving you some different parameters than in the previous problem. So we know we're going to have to handle this a little bit differently. They're also asking for some different things. They're saying calculate the total hang time of the ball, calculate the final velocity, and then calculate the maximum height above the ground. So that was asked last time. That's kind of a classic question to ask. So give myself some space here. So let's draw our picture. In this case, you're throwing it from a height of 1.5 meters above the ground. So this is the ground. This is kind of like a physics thing to draw the ground like that. And then boom, here's the ball. It goes up, and then it hits the ground here, and it starts at a displacement of 1.5 meters. So D equals 1.5 meters. Starts above the ground, and then it goes down, right? So I'm starting here, and I end here. So my displacement is this way. So I make that negative, okay? You don't care about what the rest of the path is. You start here, you end here. Where'd you go? You went downward. So your displacement is negative in your problem. Okay, what else do they tell you? They tell you the initial velocity, VI, is equal to 15 meters per second, positive 15 meters per second, because we're throwing it upward. We also know the acceleration is negative 9.8 meters per second squared. And I see 3 numbers, so we're good. We have negative 1.5 meters, 15 meters per second, and negative 9.8 meters per second squared. So if we have 3 numbers, we should be able to figure out everything else. So the first thing we're going to do is calculate the total hang time. And that's good. So the total time agrees with the fact that we know the total displacement from start to finish. So we can use I'll write them over here so we can kind of see it better. 15 meters per second. The displacement is negative 1.5 meters. There's no shame in writing the numbers again. So I like to write them in the picture, in the diagram, but also while you're doing the calculation, if you need to see them in a row like that, like I'm super used to seeing it like that. So if you need to rewrite it, that's totally fine. Write it as many times as you need to. So we need again, the equation without VF is this one. You substitute in, and then you do a facepalm because you realize, oh man, I have a t and a t squared term I'm going to have to do the quadratic equation. And that's totally fine. This is an honors class, so you are going to have to do the quadratic equation sometimes. Get used to it, okay? I know it's like a pain in the butt, but it's doable. It should be doable, okay? The only other thing I would point out again is you could do the whole thing and get the wrong answer if you don't make this displacement negative. I'll say it one more time. Remember, we started above the ground and then we ended up going downward. We went below where we started. The displacement is down negative 1.5 meters. It's important that you make that negative. So when I do the quadratic equation, I like to put everything on the appropriate side and rearrange it so that the t squared term is first, and negative 9.8 times 1/2 is negative 4.9 t squared. That's a positive 15t, and then you add 1.5 to both sides, so you get positive 1.5. Now it's positive. Before it was negative, okay? But you add it to both sides. Okay, so now this is our A term, this is our B term, this is our C term. Let's do the quadratic equation. If you want, you could write this in your reference table. I would probably put it on page 5 in the geometry section, just because it probably fits there. That has the Pythagorean theorem and all that stuff. All right, so this is A, B, C. Let's plug it in. And by the way, so it looks like that. And by the way, if you're not plugging this in your calculator in one line and doing the plus side of things, and then you go second entry in your calculator, and then you just change the plus, you could scroll over with your arrow keys and change the plus to a minus, and it should make it a little bit easier for you. So when you do all of that, you get a time of, when it's plus, you get negative 0.0969. So we'll call that 7 seconds, which seems weird. And then the second number you get is 3.16 seconds. So it's like, well, why did we get this weird answer for the time? It's because the calculator doesn't know you're doing physics. The calculator thinks you're doing the equation for a parabola. What? Yeah, we're getting a little ahead of ourselves here. When we talk about projectile motion, we talk about how this path is parabolic. And even though it's still a linear shape that we're doing, the y-axis is still kind of making that parabolic motion. So how does that tie into this? Well, if you go back in time, then it takes negative 0.097 to get to the ground. That's kind of what it's doing. It's doing the whole path, all right? And then, yeah, so we don't want to go back in time because that doesn't make any sense. So we take the positive number, time is positive, and it takes 3.16 seconds to do that path like that. So we'll box in our time over here, and we can even write it in over here equals 3.16 seconds. Then we're going to find the final velocity of the ball. I'm going to have to, I don't know if you saw the transition there, but I kind of advanced the slide too early and cut off my timing. So I'm going to erase all this stuff, and we'll find the final velocity of the ball. Okay, so now we are looking for the final velocity, VF, which is over here. And we know the total displacement from here to here is still negative 1.5 meters. Okay, so that's one piece of information that we know. We do know the initial velocity. We even now know the time, and we know the acceleration. So we could use a number of different equations since we have 4 pieces of information to find VF. If I have a choice like that, I prefer to use VF equals VI plus AT. But since we rounded our time, I'm going to actually use the equation without time. VF squared equals VI squared plus 2AD. So you can substitute in what you know. Making sure to, again, well, obviously you're accelerating downward because Earth's gravity is pulling you downward, but you started here and went here. So overall you went down, and we showed down with the negative sign. So don't forget to make them negative because that will affect your answer. So you wind up getting VF squared is equal to 254.4, and then you take the square root and you get VF is equal to 15.9 meters per second. And then you ask yourself, does it make sense that my the final velocity is greater than my initial velocity? We could ask that question first. And we said, yes, the magnitude of the final velocity should be greater because it has more time to continue to accelerate and get faster. However, look at the direction of this vector. Wouldn't you expect to get a negative number? Yeah, well, when you did the square root, your calculator was just like, you probably want the positive number, right? And they just spit out the positive number for you. But don't forget, you could make this negative 15.9, blah, blah. It's like 0.94999 times negative 15.9 is still positive 254.4. That's what this was equal to. VF squared equals 254.4. So when you take the square root of that, you just make it negative because you know you're going downward. Now for part C, and this is the reason why they always say, oh, what's the maximum height? Because at the maximum height, you have to analyze a little bit differently. You can no longer use your total time because it doesn't take the total time to get to this position. And when it's asymmetric like this, you can't just cut the time divided by 2 like we did in the previous lesson, because it's not equally divided by 2. And that's why I call it the first segment. The first segment right there, and the second segment. So you have a choice now. Do you want to look at the first segment or the second segment? It depends on what information you have. It's going to be different every single time. The thing that's the same is that the velocity at this point is 0 meters per second. But do you want to look at the first segment and make that the final velocity? Or do you want to look at the second segment, which would make that the initial velocity? Well, I think you could do it both ways because you have the acceleration. That's the same for both. So that's one piece. You have this piece here. So that's a second piece, whether you make it VI or VF. And you actually know VI on the first segment. So that's your third piece. So we know we're good. But you do know VF. We just calculated it. This is still negative 15.9, blah, blah, blah. We rounded it. So it's up to you. You could do either way. The only thing I'll say about this is don't forget, if you look at the first segment, which is what I'm going to do, I'm going to choose the first segment because I have this nice 15 meters per second that was given to me in the problem instead of a rounded answer here. So I prefer to use the non-rounded answer. So, and that's nice. We got 15, 0, negative 9.8. The only disclaimer with this is, remember, they're asking for the height above the ground. So we're going to calculate this height from where it started to the maximum height here. We cannot forget to add in this distance here, the 1.5, because it's asking above the ground. So don't let me forget now, okay? This is 1.5 plus whatever the distance is that we'll calculate right now. Okay, so if it helps, I know I said it before, if it helps, write out your givens and your unknowns again. So we're going to make this VF is equal to 0 meters per second because I'm looking at the first segment. VI is 15 meters per second over here. A is negative 9.8 meters per second squared, and we're going to look for the distance. If you want, you can write in plus 1.5 meters over here as a way to remind yourself, hey, don't forget, we want the height above the ground, so don't forget to add that 1.5 meters. That's a little pro tip for you, because after you do all the math, it's like muscle memory now. You just move on to the next one. You want to write yourself a little reminder if you need to. And so we don't care about t, So it's the same equation as part B. It's just different now because we're looking at the first segment, whereas in part B, we were looking at the entire path. So VF is 0, VI is 15. Don't forget to square it. 2 times negative 9.8. Don't forget to make that negative, times D. And you get D is equal to 11.4795, just 11.5. That's fine. 11.5 meters. Don't forget to add the 1.5 meters here. So your D max, the height above the ground, is about 13 meters. If you'd like to, you could do the second path now and see if you get the same answer. Do you get the same answer as if you're looking at the second segment, and you'll use the VF, and this, don't forget, there's a rounded number here. So you'll use the VF, you'll use the A, and this will become VI. So there's your 3 pieces of information. You're looking for the displacement. That's this total displacement. You won't have to add the 1.5 anymore because it's just from the way top to the way bottom. So you don't have to take that into account. And you'll get an answer that's close to 13. Again, we rounded here. So it's going to be 12.979 is the precise answer. Well, that's like the rounded answer that you get. But it's the maximum height is 13 meters when you round. Okay, so that was a lot of fun, wasn't it? Again, I'll say it again. A lot of people like to ask me, okay, Mr. Nangle, so is it like that every single time? And I've tried to say multiple times throughout this lesson that it's not the same every single time. The point of this is it makes you think critically about the situation, and you kind of have to work with what's given to you. And sometimes you have to think a little bit outside the box, and that's okay. That's good. And if you don't get it at first, that's totally normal. Again, I did all these problems ahead of time just to make sure I didn't make any mistakes. But it takes a little bit of time to think about it. And it's okay if it's not automatic. All right, don't rush through this. Try to understand what's happening because this is only one dimension. I said before, we're going to do projectile motion where there's an x component to your initial velocity, VIX. And right now, all we're dealing with is VIY. It's just going up and down linearly. So this is going to get a little bit tougher. So make sure you have a good base with what's happening right now before we move on. That's about it. Thanks for watching and have a great day.